Hi everyone, I'm Mistry, working as a senior software engineer at Red Hat. I work on CI infrastructure and performance in OpenShift. Let me start with a provocative idea. What if your cloud build isn't about usage, it's about blind spots? So we always think of cloud cost as compatibility, compute heavy workloads. There could be bad queries. There could be biggest cost comes from something like no one notices. For example, there could be retries when trying to pull something, or there could be some jobs that are running quietly which are consuming lots of time and wasting lots of compute hours, which doesn't make sense. So it could be different scenarios here. Who here has ever had a cloud build that they cannot explain? There could be many of you. Are there any who have seen cloud cost, but they don't know why they are racking up? So there's no way there could be this much cost, right? I see some nodding here and there, so I feel like I'm on the same page with everyone. So now, if you see your dashboard where things are running and everything is green, but you still can't show why the cost is going up, there could be some panicking from the CFOs who are looking at the finances, right? So we are here to find out the stealth cost that lies behind the stuff, and there could be some cloud inefficiencies that lies around. Today I'll share a similar story that we had a catastrophic failure in our CI infrastructure, which was racking up cost slowly and steadily, growing over time. It's about this stuff that silently loads up your resources while everything still works quietly. So your observability Slack says everything's fine. So let's buckle in and see. This is a story on the S3 storages and image corruptions. So who's on the journey with me today? Here we have a problem with the scale. So when you scale infrastructure, even with inefficiencies, things you would never care about can snowball into serious issues. A flaky upload, there could be no big deal, that's fine, right? There could be flaky uploads, but then you don't know what exactly causing those flakes. For example, there could be 3,000 flaky uploads slowly racking up your CI infrastructure cost. It's like a forest fire that's growing silently, but also it's like moving across. We can do a small napkin math where, let's say you have 3,000 flakes, you have 3,000 jobs running, which is slowly racking up, and each failure could retry 5 times, which is 15,000 times. Now you can do the small math where you don't need those 15,000 operations. You could have done within 5,000 operations. That slow cost can build up over time. But your retry logic works, so you don't need to worry. Your things are running fine, and you won't be able to catch any small differences in your day-to-day activities, which can increase by a few seconds. But those few seconds, if you compare over a longer period of time, for a year, that's a bigger cost that you're racking up. So how many of you get alerts on only hard failures, not on the slowness of the things running? It could be slower by a few seconds. Does anyone here have seen those kind of failures? I see some hands up at the back. So looks like they have seen something. Here's my favorite analogy. You can have leaky faucets. That's like few drops every second going down. But if you consume the cost for the whole year, that's a big cost showing up slowly over time. It could be 45 seconds. It could be a few seconds, but slowly it builds up. Let's talk about the symptoms that we have seen and observed in the live infrastructure. So in this graph, we talk about the pull latency that slowly creeps up over weeks of time. Let's take the timeline here, starting from April until June. It slowly creeps up. You won't be able to notice the subtle difference in those failures. It wouldn't cause a huge spike. No red alerts. It's like technical cholesterol for the jobs. It's slowly, silently clogging the CI arteries for us. Then boom, we added a small and slow fix, and you can see the latency drop significantly. That's the big achievement. Who's here has a alerting threshold that would not catch this trend? Anyone? I see some hands here and there. That's perfect. So that's the thing. This wasn't a failure, it was inefficiency. Just a small inefficiency growing slowly enough to pass underneath the radar. And you can't even imagine. This wasn't the system. It was just retrying like a loyal golden retriever whose it impacts real ops. So let's say each retry adds maybe 15 to 20 seconds. Not too much, right? So every time 3,000 jobs run over few seconds, it's 10 plus hours daily wasted time quickly, and you wouldn't realize those few seconds. That's hiring a junior who only runs OC get pods and then goes home worse. These retries generate cloud egress traffic with extra compute and targeted longer pipeline times. Overall, it increases our cost. So moving on to the next one, the OpenShift image storage cases. Here's the root cause. We use Docker distribution backend by S3 storages. Standard stuff, right? When you push an image, it breaks into multiple layers and uploads parallelly using the S3 multipart APIs. On paper, it's brilliant. Parallel, uploads faster, cheaper, right? Does anyone understand that? Based on the topic that if it uploads parallelly and smaller, you wouldn't even notice that things are moving slowly, but also steadily. Some of these uploads were silently failing, especially underneath pressure, and only later on when you try to pull an image, you realize that some layers are missing. So when those layers are missing, that's when you know the manifest is corrupted. You can't able to use anything that you uploaded in quite a while. Are your jobs failing inconsistently because of this failure? That's the problem. You wouldn't able to realize until later on you try to use them. How many of you trust S3 just works? I see quite a lot of hands here. That's great. So we also thought the same. S3 just works. It's perfect. No need to worry about that. Turns out there was some image manifest we are referencing blobs that never finished uploading, causing us problems because multipart failed silently halfway through. The registry didn't notice that. That's the problem. Next level, ghosting. S3 said upload succeeded, so we never know what exactly caused the problem. But a chunk was missing. A small piece of missing layer caused the whole problem. Now, let's see what those corrupted images got cached. Then we again use the same cache, causing the retries over and over again, building up more time. So every future pull hits, hitting the same missing blob over and over until someone manually goes and digs in and find out why that blob was missing in the first place. Wait, this isn't a flake, it's just a retry. Something goes wrong, we just retry, it works, that's perfectly fine. Nobody cares anymore. That moment was the same like a matrix glitch. It just happens, you didn't realize, it just happens again. You just let it go. But then we dig deeper into this topic and we try to investigate the bottleneck. Let me walk you through to the diagram, how an image push should work. More like layers go into S3 using a multipart upload. Manifest references each of the individual layers and pulls later reads that the manifest and fetch blobs. Looks like right. Here's what we actually happened. The multiparts were partially succeeding. There was just a small chunk missing, causing the whole layer to fail, but not the whole manifest to fail. Some blobs didn't finish. Maybe a network blip, maybe throttling, could be anything. But S3 will give back 200 response, which everybody feels, okay, things are working fine. we don't have to worry. So the registry thought it was done and hopefully wrote a manifest referring to it. The blobs didn't say fully exist. So there's a question for everyone here. Anyone ever saw a green check mark for this stuff and trusted your CI is working fine, you don't have to worry, but it was lying? You never saw that it was lying, right? You saw that it's working fine and you don't have to worry anymore on that. That's what happened with us as well. It said upload complete, we are fine, so we never cared about it and ignored everything that's going in the background. But the registry never verified the blob. That's where the problem comes in. Unless we verify that everything that we uploaded is to the point, up to the mark that the image can be worked perfectly fine, then we are good to go. So we never try to check the blob hash before moving into the storage. We never did. It just goes and pushes everything what it saw at the beginning. Boom. That's when there's an unknown blob in the registry, because now there is something missing that we cannot find. So this diagram is all about that. When we try to push it, something goes missing. It just finalizes the manifest inside the registry, and there's a pull attempt failures when the user or anyone else try to use that uploaded image directly from the storage. In this case, let's just say it was an S3 storage. So how do you add more visibility and test to it? You can add visibility not just by logs, but intentionally you need to have some instrumentation set in place. For example, measure the pull durations that access through different clusters or different storages across the globe. Track blob access patterns. You can have the different patterns going on around and detect repeating failures. That's how you can try to analyze a common pattern across the board. It might take time to find the pattern, but that's crucial. This is what I call observability judo, where using our platform's own behavior against itself to find the hidden bugs. We also built a lot of internal tools to track it down. Let's just say count how many images you pull every single time there's an incomplete manifest. That's a matrix you would like to know about. You can monitor all the retries where the blobs are missing and check the granularity level by level across the time. So you know if something is missing over time and it keeps growing, you have the matrix that this is a problem. This is nothing but an inconsistent pattern that we have observed over time. Have any of you added an alert that you hope never fires? Anyone has added? Like you don't care about the alerts, but this should not fire any single time. Right, I see some of the hands here and there in between. Perfect. That's what happened. Our dashboard lit up suddenly. Turned out it was just 5 or 7% image pull failures. Nobody usually cares unless it's like a 50 or 20%. It's just 5%. It could be something, or it could be just a network issue, just a retry, and we are fine. So that's the crazy part. We had near zero visibility into this, and we wrote our own blob checker scripts to verify each script every single time. Make sure everything goes in perfectly, and we verify on the other end that everything was uploaded and we are able to use it. That's more like a debugging tool we try to use, which isn't a log, but it's just a little constructed paranoia for our testing purpose. On this one, that's one of the hero of our story, the pull request number 43 in the Docker distribution. We fixed the issue at the source, the upload process. Here's what we did. After the multipart upload, explicitly verify each blob hash before writing the manifest. If it didn't match, we abort the push. That's it, period. Adding retries at the upload image, not just pull. This is like checking your luggage before the plane leaves. Make sure your luggage is there before you go out of the plane, right? So, quick dev humor for all of you guys. CI is just like a toddler who likes to eat sugar candies, but if you give too much sugar, you get a sugar crash instantly. So you need to feed clean images as well, or otherwise it will start throwing tantrums at us. The PR was added for better logging around, but also we had upload failures, we had partial correctness, and also both references in manifest. We merged the fix, we roll out in stages to make sure the fix actually worked, and it's not just like another retry storm going on again and again without verifying. We also verified the egress cost. It went down. We saw the pull latency. It also went down. And the stress level for everyone, it also went down, like everyone can imagine. If the traffic is less, the cost is less, everyone's happy. No stress for the finances, right? So there's a bigger question for everyone here. Anyone ever merged something and immediately started stalking Prometheus, look at the data if everything is working? No, you don't care about the data. You always upload the PR and just forget about it. You always try to look, right? What's going on, if it worked or not, right? So here, we try to measure the changes that we merged. The perfect way to do that is look at the success story. We try to check the average pull latency, which dropped by 30 to 40%, which is a good number. It's not like 1 or 2, it's a bigger number. We also see the retry fell down completely. That's way below retry count than usual over time. Also, the blob mismatch errors, it vanished completely from the pipeline. Earlier, we used to get at least 10 to 15 questions from different users every single hour. Now, we hardly get one question over the period of a month. So that's a big progress. So what's the biggest performance you have ever seen on a one-line fix? Anyone has seen a bigger performance in just one-line fix? Can you name one? That's a good answer, if you can't remember. All right. So we also saw reduced load on our S3 bucket, smaller cloud builds, especially the egress charges, and fewer flaky test failures, because retries weren't eating timeouts. The timeouts are the biggest concern over here. It just happens slowly and steadily. And you know what else? They have helped trust our engineers stop saying CI is flaky. That's the biggest achievement, because when CI is flaky, that's a problem. It's a reminder that performance isn't just numbers, it's confidence in the system by the users. If they trust the system, that's the perfect system that we can build and improve on. It's also faster, cheaper, and cleaner over time. So this is more like a trade-off triangle. You can't have everything at the same time. You can balance a little bit, but not everything. It's just mysterious, just like my name. So this is the classic. Speed, reliability, cost. You can pick any two, right? Many of you would try to pick all three at the same time, but you might trade off something here and there. So who's here had to explain the leadership why the fast, cheap solution wasn't reliable? Anyone had to explain that? You had to explain? Perfect. So you know the overlay of our content right now. We need fast image pulls to keep CI pipelines snappy. We also wanted low egress cost for storages, so we can scale at large, because that's a bigger number. Every byte matters every single time. And we couldn't compromise on reliability, because flaky CI underlies everything else. So the root cause hit us right in the center of the triangle. To fix it, we added some overhead validation checks, cost a bit of a time, or I would say a bit of a longer time for a few weeks. That's debatable. But also gained a massive reliability during pulls and reduced overall due to the fewer cost. fewer retries, and less network traffic latencies. So something else slowing us down helps us go faster to understand the problems. Moving on to the next, we can framework diagnosing storage issues. How did we find this? It wasn't just a magic. It was a mindset. Diagnose like a detective. Here's the rough framework, and then there we go. So let me explain a little bit about the framework so you guys have a little bit better understanding. Start with a symptom: slow CI, high egress. Trace the behavior, pulling same image over time, same registry, retries, right? It goes on and on. Then we try to collect supportive evidence. What happens? Logs, metrics, even user complaints. That's also important. Reproduce if possible. Can be simulated? If not, then we can try something else. Narrow the suspect. Is it a network? Is it a storage? Is it an image builder? Something else? It could be anything. Confirm with the data we have. Assume is not going to work. We have to make sure that we find the final answer for this problem. So debugging in production is like solving a murder mystery, except the killer might be the server itself, or it could have already been restored by the time we try to investigate. The symptoms can be CI slows down, behavior, image pull retries, evidence, could be blob fetch errors, reproduction, pull images. You need to use different registries and try to verify. The suspect could be anything. But you try to add trace logs, you try to validate each object store caches, and you try to reproduce everything. This isn't just a one-time playbook. It's a repetitive progress. So let's just zoom out a little bit and see what are the best practices we can take away from this. We can validate before the trust. So make sure that the cloud provider says okay. It doesn't mean your upload succeeded. You have to verify yourself. Measure the user-facing latency. Make sure that it's not just internal metrics. What your system thinks, it's fast, it doesn't matter. If the users are still waiting, there's a problem. Layers in observability. Add just enough to catch the small anomalies before users do, so that you know before anyone else. Test the failures path explicitly. Make sure the storages is where the issue lies, are not the silent ones. Deploy in stages. Monitor closely so that you know when touching anything, it's related to CI or image registry, or you can quickly catch the problem. And also, bonus tip from my side, have someone on your team whose job is to just be suspicious of things that are running around. Just be suspicious about anything. Even if it's right, just be suspicious about that. So that's the real MVP in our team. We made a postmortem doc and a quick presentation internally to teach each other, but it didn't work. So we had to make sure that we provide every single details to everyone, including the QA, including the builders, including the SRE, or anyone else around, so that they are also aware this is the problem. So it's not just about OpenShift that we work on. You can apply the same concept across everywhere else. In this case, it could be CI/CD artifact storage, it could be CDN, caches, registries, any distributed file object systems. You can work across everything else. Key takeaways. Let's wrap up with some key takeaways. And yes, exactly, you would like a meme as well. That's the fun way to do it. So a green check mark doesn't mean everything. It's actually okay. So you can have tiny inconsistencies scale outside. You can validate the writes. Don't assume everything. And infrastructure and app must align, right? Infrastructure will always say everything looks fine, but storage actually knows, is it actually fine? You have to go and verify yourself. So performance tuning isn't about making things faster. It's about making things reliable, predictable, and honestly, a little more boring, because when infra is boring, devs are happy. Any more questions? Anything from anyone? I would love to take more questions about storage, registries, containers, diagnosing, or any other differences. If you like the PR, you want to take a look at, it's sort of linked in the presentation. But I'll open the space for any questions from anyone here. Go ahead.
So, which S3 implementation were you using? Was that Amazon Web Service? That would be my first question. And my second question is that the snippet of code that you showed, where you do the checksum validations of the uploaded layers, is that something that you added as a step in the pipeline, or is that something that you added in the container runtime code? Because if this is a generic issue with S3 that it lacks checksummings of blobs, it should be maybe in the container runtime code, this kind of checksum.
Right, so I'll take your two-part question. The first one is it the S3 from the Amazon Web Services API we use? That's the same one. We use Amazon S3 API services for that. The second question you had is this snippet that we added was inside the pipeline or the runtime code? It's inside the runtime code so that it's checked across the registries and repositories that can be used globally by everyone. It's in the Docker distribution everywhere else, which is used. Any more questions? All right, I think there's no more questions, so I just leave up the link. Thank you everyone for joining in the presentation and giving the time. I'm happy to connect offline if anyone wants to connect about debugging something similar they are working on.